Hello and welcome to episode number 23 of Tradecraft Security Weekly. I'm your host, Beau Bullock. I have Mike Felch with me once again. And this week we're going to be talking about HTML5 storage, Exfil via XSS. And more specifically, we got a request on Twitter to do an episode generally about how you go about exploiting XSS and CSRF vulnerabilities. I think a lot of people, they might see that pop up in a vuln scan and kind of wonder what does that actually mean in terms of stealing somebody's session, or how would you actually go about weaponizing it. So I think that's kind of what we threw this episode together for.
All right, and then the HTML5 storage component was useful because we were just on a recent CTF, and in that CTF, I don't want to put it out there and spoil anything, but they were using HTML5 storage and cross-site scripts in order to do some bypasses. So it was kind of good timing all the way around.
Awesome.
Cool. So I guess to get started, maybe we could talk about a little bit about the different types of cross-site scripts. There's a handful.
Absolutely. Yeah, so you have your typical reflected cross-site scripting attack where essentially that's your basic, if I give you a URL, you go to that URL with the specific script in the URL and a parameter, and it loads, basically reflecting it off the web application itself. Where that differs from, say, a persistent is where, as an attacker, you can actually inject a payload into the page and it stays there. So anyone like that, a good example of that would be like a forum or something, where you could maybe post a forum post with like a cross-site scripting payload, and then anyone who visits that forum now will have that script pop up in the browser. And then, DOM-based stuff as well.
Yeah, so with the DOM base, it's kind of more on the client side only, right? It never actually hits the server, whereas on the other two, the server's taking it and processing the payload in order to render it within the HTML in the browser. DOM base is mainly where it's never actually hitting the server. It's just being manipulated.
All client side.
Right, client side. So that's kind of the difference. And then there's a few other cool things that you could do with cross-site scripts, like redressing HTML. I threw them in here, even though they're not technically executing JavaScript. They're still super useful for doing like HTML injections if you're trying to redress the page in order to kind of social engineer or phish something. And then I threw in the cross-site request forgery also to kind of talk about just briefly, because cross-site request forgeries are super awesome in that if you find if you find a page that's vulnerable to a cross-site request forgery, you're basically able to trick actions for a user. So you can embed like a post, or not a post, but like a get request with some parameters in an image tag, and then have a user kind of browse to that and then actually execute actions within the context of the web application on behalf of the user. So when you kind of get into cross-site scripts and CSRF together, you can do some pretty cool stuff.
So like a good example of that would be like change a user's password or something.
Right.
Or change their email address to your email address.
Right.
And all they really had to do was just visit a malicious link, and then in the context of the web application, it's now changed to what you want as the attacker.
So it's pretty cool. Oops. Okay, cool. So next, let's talk about HTML5 storage real quick. It's client-side storage that's in the browser versus server-side storage like in a database, right? So it's kind of like an offline storage. And it's a cool way to kind of persist data for a user that's coming back to your site. I've seen it where people don't want to show pop-ups to the user more than once, and so they store whether they've already shown a pop-up to the user or however you want. But a lot of people actually use it for session-based authentication, which I think is horrible, right? So HTML5 should never be trusted, or local storage should never be trusted for that kind of data. Because if you get one cross-site script, which is what we're going to show you, you could actually take every item within the local storage and exfil it off to yourself.
Are there any sort of security protections like the HTTP only or secure flags for local storage?
So it's a little bit tricky because each object that's stored in local storage is governed by the same origin policy, which is basically the protocol, the host, and the port, right? So those three things govern whether or not that object is accessible. And so whereas a lot of times you could set like a cookie context to only be useful for like a certain URI of a URL, you can't do that with local storage. So it's really a bad idea to store anything that's sensitive in here for two reasons, and we have them kind of here outlined. You could take everything out of local storage and pull it to offsite. The other thing that you can do is you can manipulate the data that's already in there because you can write to the HTML5 storage and then trick applications
So
later
you might have
on.
like a session fixation kind of vulnerability at that point.
Yeah, you could. Yeah, absolutely. So you just got to be careful of what you're storing in here. Nothing sensitive. A lot of people are pretty good with using it if they need it for like application non-sensitive reasons. But when you start using it for like a session token and storing sensitive data in there, it gets bad really quick. So when looking for them, when we're looking for cross-site scripts, I mean, a lot of when we're on these pen tests and these engagements, we're looking at across the whole entire application stack, right? So we're looking at the URL for get parameters to see what they're vulnerable. We're looking at different forms to see what's being posted to the server to see if any of those form attributes are being vulnerable. And then a lot of times it goes overlooked, but sometimes within the context of the page, developers will embed request headers like a user agent. It'll check the user agent in some JavaScript, but that user agent's actually in the request header. So if you look at it from that perspective, you could easily see how that can get bad.
I've had a few examples similar to what you were just saying, where the page is actually almost like a debugging type of situation where they're just trying to debug like a number of different attributes about the user that's actually hitting their application. And a lot of times, like you said, like they'll include like the user agent. So if I can manipulate the user agent into being a cross-site script, that might be a potential payload for that kind of situation.
Right. Yep. And then also on the cookies, right? Sometimes there's cookie parameters that are in there that are actually rendered within the HTML5 as well, or HTML as well in the browser. So just some ideas on where you're looking at and when you're trying to identify these. So what we're going to kind of step through real quick is just a simple scenario. We're going to inject a cross-site script into an error parameter using a get. Obviously, this is a non-persistent one, so this is just more of like a reflection attack. We're going to steal a local storage token. So in this application, it's written in Django. It's just kind of, or a Python Flask. It's basically going to just generate a random token on the backside on the server and then render it within the code. And then we're going to exfil that token and then send it to our site offsite and kind of be done. So that'll be the demo. So
awesome.
Cool.
Yeah.
Cool. So let's go ahead and jump into the demo real quick. So what I have here is I have this host is basically generating the token and it's rendering it in this page. And you can see it. It's actually stored in local storage. So let me just pull it using get item. And that's going to show basically that this value is stored in it's echoed back to the screen. But we also see here there's this error, right? So if I pass in this error parameter, it'll be rendered on the screen. So we're gonna leverage this vulnerability here, which is a unsanitized parameter that's rendering it on the screen. And what's going to end up happening is we're going to steal the cookie here. So you can see just your standard script as it's being rendered. So you see there's the vulnerability right there. So what I'm going to do is I already have a copy here. I'll step through this real quick. This is just a basic script. It's using jQuery because I already have jQuery running in the background. We're going to call a GET request to a site that we also own, and we're going to concatenate the local storage get item. And so basically what's going to end up happening is it's going to execute this JavaScript. It's going to call a jQuery GET to our host, and then pass in that as the token as a parameter. So let me just take that. I'll copy it over.
And for your typical session management with the uses typical cookies, you could use like document.cookie with a similar
absolutely
payload.
Yeah, you could use whatever payload that you're trying to pull. In this case, we're just doing it with local storage, but this could have been document.cookie, but we're pulling it out of HTML5 in this case, so that's what we're doing. So we won't see anything render here. And so what you're going to notice is on this page over here is just a sample site. So I have it here. You see the request that came in. There's the first request. There's the second request. And then once we look at it over here, we see another web request. This is the listening page for the sniped.poppingboxes.org. And so you see right here, there's our token that was requested and exfilled to our server. And that's pretty much the demo, really. I mean, it's not too much to it. It's fairly straightforward.
Yeah, but this gives a good example for how to actually go about weaponizing and attacking sites that are vulnerable to XSS. I mean, it really shows that, if they're not protecting the session tokens in some manner, then it's easy to steal somebody's session and be them in the application.
Right, because now you could take that token and then just inject it into your own HTML5 storage, go back to the page, rebrowse, and now you'll have an authenticated session.
Exactly.
Right? So similar to the document.cookie, stealing the cookie, loading the cookie in the cookie, like a cookie manager, and then being able to browse back and have that session there.
Absolutely.
So just some additional ideas. These are really cool. So load external scripts via cross-site script. So instead of actually putting the cross-site script in that error tag, just load script source to an external source. That way you can manipulate it on the fly, right? So if you wanted to change it, or you wanted to add more to it, or if you wanted to weaponize it into a worm, you could always just build off that and keep loading it. The other thing that you might want to do is inject these payloads regularly, but do it in a way where you know where they originated from. Because if you do that and you inject it where they phone home to like an attacker controlled server, you can find blind cross-site scripts. And this is a lot of times what you'll see in like the bug bounties on HackerOne or BugCrowd. What they'll do is they'll inject these payloads into these forms. Now they're blind because they don't know that there's a cross-site script there. But when an administrator logs into the back end, that cross-site script triggers, it phones home. Now that bug bounty, what do you call them? Bug hunter.
Yeah.
The bug hunter knows that there's a vulnerable script at what location of what application for that host, and then they could file a bug and actually get a bounty on that. If you combine cross-site scripts with these cross-site request forgeries, it could be really damaging, because a lot of times a cross-site request forgery might have some sort of prevention, like a token that's blocking that from, like, these actions from triggering on behalf of a user. But with a cross-site script, you could steal the token and then bypass that by just passing the token with the cross-site request forgery. And then a lot of times you'll see a lot of bypasses, right? You see these all the time. So we'll see people trying to filter out like script, or they'll filter just on a whole range of filters.
Certain characters, certain parts that are typically included in scripts. I mean, we see WAFs a lot that are pretty decent at detecting the majority of the common bypass techniques, but there's always ways to get around that stuff these days.
Yeah, absolutely.
Seems like people come up with bypasses every single day.
Yep. So there's a whole list of them on OWASP. I think we have a whole bunch of them. And then another way for testing a range of them is using polyglots. This was a really cool thing. It's like a polyglot is a big JavaScript that has a bunch of tests in it, so you could kind of test a bunch of bypasses all at once. So you just kind of copy it in and you're good there. Cool. So mitigations. Talk about how to block some of this stuff. Escape HTML, escape the attributes, everything to do with what's rendering in the browser. We want to sanitize everything from JSON results coming back from a AJAX call or some sort of call on the back end, to loading CSS and URLs. We want to sanitize everything that we possibly can, and we want to do it with hex entities if we can, right? So we want to try to convert the @ symbol to, or the N symbol to the AMP, and so on, so on. The other thing is there's a lot of really good mature HTML sanitization libraries. So don't try to roll your own. You're going to run into all of these bypasses yourself. It's rather a really good idea to use one built for your language.
And also kind of implement like a defense in depth perspective for your web apps too, like, because we see a lot of times where somebody just literally all they do is throw WAF in front of a really, really bad web application and expect that to protect it. True. But you do need to do the due diligence and actually protect the sessions from a web app level. Yep,
absolutely. And then the other cool thing that you can do for cookies is HTTP only and secure flags. HTTP only is going to make it so that JavaScript can't access your cookies. Secure flags is just going to make sure that cookie is not sent over HTTP, only HTTPS. And then finally, obviously, content security policy to restrict or to whitelist where your resources are being loaded. That way there's no JavaScript that is an external JavaScript that's being loaded from an external source. And then, so that's pretty good. I think that's pretty...
Yeah, that was a great episode. Yeah, thanks, Mike. We appreciate you guys for listening in. If you have any ideas or anything that you want to see on the show, feel free to ping us on Twitter. We're at StaffTac, and you stay ready. Thanks so much for watching. See you next week.
Thanks.